Breaky Heart, KDE, and Elton John. Banana phone. Yeah, banana phones are just the idea. How much time do we have? Ding dong, ding dong, ding dong, ding, banana phone. I got this feeling, it's so appealing for us to get together and sing, scoodly doodly doop. That? We still have a minute to go, so I can. Putting on the Ritz? No, I can't. I cannot tap dance. I can square dance though, so this gives me another 30 seconds to promote the square dance workshop on Tuesday. You've got about 30 seconds left. Are you ready?
No.
Are you ready?
Yes. Ask me again.
Are you still ready? You are ready. Well, welcome back from coffee. I hope everyone is energized, fed, bathroomed, etc. We're here to listen to Nicolas, who will be talking about documentation things. Nicolas, speak into one of the microphones.
Hello, welcome to the how does any of this even work part of today. First of all, a question. How many documentation web pages do we have in KDE? The answer might shock you. We have a bunch of them. First and foremost, we have api.kde.org for our API documentation. Then we have docs.kde.org for user manual documentation. We have develop.kde.org as a sort of developer center with documentation as more tutorials, use case driven, and so on. And if that wasn't enough already, we also have a bunch of wikis, free, that also have documentation in them. For the purpose of this talk, I'm gonna ignore all of them except the first one. So let's talk about API.kde.org. First of all, why do we even do API documentation? As an application developer, you want to, when you want to write a KDE application, you want to, of course, know what APIs are there even available. So just having a list of all the KDE frameworks and other libraries that KDE has to offer for application development. And then, of course, you don't only want to know about does the library exist, you also want to know what classes are available, which methods do these classes have, which properties, and what do I need to know when using the class? What might be the pitfalls, the limitations, all of the interesting stuff that you don't immediately can infer just from looking at the function signature. And we not only have that for C++, we also have QML API, we have some amount of JavaScript API, and if you listened to my talk yesterday about language bindings, in the not so distant future, we also might want or need to have API documentation for Python APIs and Rust APIs, and potentially even more languages in the future. So what do we have right now? Right now, api.kde.org, I trust that most of you have seen it at some point, is based on Doxygen. Doxygen is a fairly widely used and flexible tool for generating documentation for C++ code. It parses your code, looks at documentation comments, extracts all of that, and dumps out a nice web page for you. Being as flexible as it is, it's in my opinion not always very intuitive to use. I have a feeling that most people who are working in KDE don't know all of the things they can do with Doxygen. They just copy what they see elsewhere and hope that it works. But few people really understand all of the things you can do in Doxygen. but it's manageable. The much bigger problem is that Doxygen doesn't really have a good understanding of a lot of the concepts you find in Qt code. It has some of that, like it understands signal, it understands properties, but out of the box, it has absolutely no clue about anything QML. And that's a problem, because we have a lot of QML-based APIs that we want people to use. A while ago, we came up with a sort of glorious hack for that, which is called DoxyQML. What this does is, you write QML code, you write Doxygen-style documentation comments for that. We feed that into DoxyQML, which turns that into C++-ish code that Doxygen can parse. And then we run Doxygen on that, and the output more or less looks like you are documenting a C++ class. There are ways to get that somewhat better, but overall it's not a good experience, and it does not feel right. Content-wise, API KDE org is sort of a mixed bag. Some of the content is actually really good and really detailed. Some of it is not up to date and still stuck in KF5 or even earlier times. Some of it is outright missing, and there's functions that just don't have any documentation whatsoever. So overall, the situation is not great. So we figured, especially in line with the streamlined application development experience goal, we had to do something. So one thing we looked at when discussing our options there is, what does Qt do? Because Qt maintains its own documentation tooling system called QDoc. And being developed by Qt for Qt, it is laser focused on supporting the things that you need to do to support documenting Qt code. And that means support for documenting C++ APIs, but also QML APIs. So if you look at the documentation for any QML APIs from Qt, that looks miles better than anything we have on API KDE org. And it's also actively maintained and developed with new features. And overall, it seemed like it could be a very good fit for KDE. So, case solved, let's use it then. Well, not so simple. The idea of using QDoc in KDE has been discussed before. I did not come up with that. But anytime we discussed it in the past, people did find some blockers. The most important one that was constantly raised was, for reasons that I don't know, unlike Doxygen, QDoc expects documentation comments in the C++ implementation files, not in the header where Doxygen looks for them. That might seem inconsequential at first, but it does break things like your IDE automatically pulling documentation from the symbol you're looking at, which was a huge deal breaker for some people. Then QDoc uses a slightly different markup than Doxygen. It's conceptually similar in many ways, but different enough that it's not something you can just easily convert, and it would be a bit of work. And if we did that, then we would also need to make sure that we can actually build and deploy our API documentation using QDoc on the actual website. So with all of that in mind, I was musing a bit about it, and then a thought crossed my brain, a thought that has gotten many of us in trouble before, but sometimes results in great things. I was thinking, how hard can it be to fix that? So, QDoc internally for parsing and processing C++ code is using libclang. that is in many ways a very sensible choice, because that means QDoc has excellent support for all sorts of syntax things in C++. Slight downside to that is it means the parsing is not very fast, because Clang is, for this case at least, probably more precise than it has to be. But overall, sensible architecture on the QDoc side. So I dove a bit into the source code, and a little bit of hacking later, I had something that worked, and I could have documentation comments in my headers. Then, being the good open source citizen that I am, I of course uploaded the patch to Qt. They had some feedback, and after some back and forth and some discussions, together with the help from the QDoc team at the Qt company, we managed to finish the patch, and it's available since Qt 6.9. Yay! Now, before we get into more documentation stuff, we need to talk about owls, specifically how to draw them. First of all, you draw some circles. Step 2, you draw the rest of the owl. What does that tell us about QDoc? Well, I had some technically rather impressive circles now. Now I just needed to do the rest of it. What does that rest look like? To answer that, we need to look a bit into the anatomy of QDoc and how it works. The centerpiece of it is a command line tool called QDoc, which is controlled by a bunch of files ending in .qdocconf that describe various properties about your project. It can also include additional files that also have documentation content, so not only headers and source files. And in order to do its job, and in order for the Clang-based parser to be able to parse your code, it needs some extra information. It needs things like your include directories, the compile definitions, so that Clang can actually understand all the includes and decode and so on. Unfortunately, all of that information can get rather complex, especially if you have large projects like Kio, for example, with dozens of dependencies. And it's also very specific to the machine and the installation that you have, because dependencies might be of different versions or in different folders and so on and so forth. So invoking QDoc on the command line can get rather complex very fast, to the point that you can't sensibly do it by hand. So what we really need is something that knows how to build your project, knows about all the include paths, compile definitions, dependency locations, and so on. Fortunately for us, we have that thing. That's right, I'm talking about CMake. So CMake to the rescue. CMake knows about our dependencies, where they are, how to build against them, and CMake can run custom commands for us. Long story short, we got a new function in extra CMake modules called ECM generate QDoc that takes a target, takes a QDoc conf file, and it gives your project an extra build target so you can make documentation, and in the end, you get documentation. So all of the gory details about include paths and compiler flags is all very nicely abstracted away. Next, we have the aforementioned QDoc.conf files. Those define things about your projects like what's the name of the project, where does the source code live, which source code files should I not look into for documentation. Right now, the feature for QDoc to extract the comments from headers is behind an opt-in flag, so we need to opt into that in the QDoc.conf file. You also sometimes want to specify dependencies for the documentation of your project, and you can also provide some additional metadata to tweak the output of the resulting HTML documentation or the QCompest help files that Qt Assistant can consume that can also be generated by this process. And it can also include other QDoc conf files, so you can structure your documentation config a bit more like a software project where you include different files and different modules. I've mentioned dependencies, so you might wonder, why do I need to explicitly specify them if the build system knows about dependencies already? The thing is, sometimes the documentation for a given library depends on the documentation for another library. For example, if we have a class like QDoc application launcher job, which lives in the QDoc repository and project, that extends kjob, which is a class that lives in a different library, in kcore add-ons. So when we generate the documentation for application launcher job, that documentation wants to link to the documentation from kcore add-ons. So if you have at the top this class application launcher job extends kjob, and you click on that, you want to be taken to the correct site. And those sort of documentation dependencies do not necessarily reflect the actual library dependencies on a source code level. For example, QDoc is using a bunch of libraries internally that don't necessarily pop up in the API and by extension in the documentation. And the other way around, it might mention types in its documentation that it doesn't actually use or link against in its own implementation. So we can't just rely on dependency information from the build system alone. Another quirk to consider here is it's very easy and sometimes very important to have cycles in these dependencies. So maybe the documentation for kcore add-ons wants to link against the documentation for QDoc and the other way around. On a source code level, that would be a huge no-no because you couldn't compile that reasonably. But from a documentation point of view, it's something we have to be able to deal with. So how do we do that? The answer is we're going to split the generation of the documentation into two distinct phases. Phase one is the prepare phase. What this does is we have all the projects, and then for each project, QDoc looks at the source code and all of the configuration, parses it, extracts all the information, and then puts it into a sort of database called an index file. And then we do that for all of the projects. Then only comes the second phase. The second phase is called generate, where the system takes those index files and all the information encoded in them and then turns it into the actual HTML files as a result. And at that point, all of the index files for all the projects are available, so it can properly do all of the cross-linking, and dependency cycles are not a problem. Enough about the theory, let's look a bit into syntax. So this is a very basic example about documenting a class in QDoc syntax. You see the syntax for the documentation comment is slightly different to Doxygen. In Doxygen we are used to /**. Here we have /**!! That's just how it is. And then we have a comment. That comment can contain a bunch of commands. Commands in QDoc all start with a \. In Doxygen you could also use @ but also \. In QDoc it's just \. Then we have, for example, \class foo bar, because we have a class bar in the namespace foo. We specify which module contains this, that's module foo, and we exactly specify how this class should be included, because following KDE header conventions, if a class bar is a namespace foo, then you should write include foo/bar. And by specifying this in header file, we tell QDoc to emit that. Then we can write a brief description of the class and then hopefully some longer explanation of what the class does. Documenting methods looks very similar. We want to have the same comment syntax. We write some description, then we have parameters, which we document with \a, and then we write something what the function returns. So looks on the surface at least very similar to what we are used with Doxygen. Now, the 90% of the reason we're doing all of this is because we want to properly document QML API. So how does that look like? Instead of \class, we have \QML type here. We give it a name. And then we have \in QML module, where we say which is the module that this type contains. And QDoc turns that into the instructions on how to import that type. Then again, we give it a brief description and a longer description, hopefully longer than does things, because, but yeah, conceptually shouldn't be surprising to anyone. And one important thing also is this does not only work for QML code files, it also works for types that are written in C++ but are exposed to QML. Then we have properties. Here we unfortunately need to differentiate between QProperties that are just exposed to C++ and properties that are exposed to QML. In the C++ case, we have the case below. We just write \property, then give it class name, property name, and a description, and the rest is mostly infer just from parsing the code. With properties exposed to QML, it's a bit different because we write QML property, and then we need to explicitly specify the type that is being used. And specifically the type how QML sees it, not how C++ sees it. So for example, the property here is of type QString, but there is no QString in QML, there's just string lowercase. Or for example, in C++ you would have QReal or QRect, and then in QML you just have real or rect. But it's something you get used to eventually. One thing where the syntax deviates the most from Doxygen is enums, because in Doxygen you can do the description sort of inline for each item of the enum. That doesn't work in QDoc. Instead, in the big comment at the start of the enum, you have to describe each value. That was probably the most annoying thing when doing the syntax conversion, but it's manageable. There's loads of more commands that I could get into, but I'm not going to because we don't have the time for that. There's sins, you can include code, you can include QML code, you can do lists, you can mark things as deprecated, you can do all sorts of things, even including things like linking to YouTube videos. Some of the key differences to Doxygen in terms of syntax is we don't have an equivalent to @author, but I don't think that's a huge loss because most of the times that I've seen it, it has been either useless, outdated, or both. There's no @returns. You just write some free-form statement like returns something something. And the way \a works is slightly different to @p in Doxygen because @p was more of a structural thing, whereas \a is more of a markup thing and doesn't have quite the same structural implications that it had in Doxygen. So now that we did all this, we just need to tie it all together and actually put it onto the website. The API KDE.org website is built in a GitLab CI pipeline, as most modern things are, and it roughly works that way. We fetch all of the projects that we want to have documentation for. There's a list for that. And then because all of the generation process is integrated into CMake, we need to actually run CMake for all of the projects, meaning we need to have all of the build dependencies available. Fortunately, that is very easy to achieve within our CI system because we have, well, previously it was Docker images, now it's virtual machines that have all the dependencies, and we have tooling to fetch all the KDE dependencies based on the KDE CI YAML files. And so it's basically piggybacking on all of the existing CI infrastructure. And then for all of the projects, we run the prepare phase, index files are generated. We run the generate phase, output is HTML files, and then we take the result and publish it on the website out in the world. And because our projects tend to be very similar, we have a lot of common configuration for the documentation between all of them. So we extracted all of that in a separate repository called KDE QDoc Common, which is a central point for that kind of thing. It also defines the index page you see when you go to API KDE.org. And in that sense, it sort of supersedes the older KAPI docs repository. So where does that leave us? I am very happy to report that after a bit more than a year of work, today we finally published the new API KDE.org website. You can look at it right now. Woo! It comes out of the box with all frameworks being converted to the new system and now are available in a much better quality. Unfortunately, we have not yet been able to convert all of the projects that we have to the new system. There's no real technical blockers for that. It's just that somebody needs to sit down and do it, and we haven't done it for all the projects. So for some of them, we still include the old HTML code just to be able to see things. It will not get updates anymore. So if you want to see updated documentation for those projects, please consider porting them to the new system. Now that we did all of that, the content of the documentation also needs some attention. Like I've mentioned, some of it is outdated, some of them is outright missing, and some of them could just be updated in general. One thing we are unfortunately losing right now is a search functionality on the website directly, because QDoc itself does not come with a search functionality in itself. The Qt documentation solves that by basically incorporating Google search into the website, but I figured that doing that for our site would not go down well with you, so I did not do that. Unfortunately, it means right now we don't have anything. There are some prototypes for having a self-hosted search for that, but unfortunately it's not finished yet. So if you have some spare time and some web dev experience, consider helping out here. Until then, you can use a regular search engine to search on the site and still get some results. And now that we have this mostly done, I'm going to circle back to what I said in the beginning about our different and other documentation websites. Should we use this new QDoc system, which I think works very well, not only for API documentation, but it allows you to also write like free-form tutorial, more text-based documentation? There's very little technical reasons why we couldn't use that to replace, for example, the infrastructure we have on develop KDE.org. So maybe something to consider for the future. Before we take a look at the new site, I have to thank some people. First of all, I want to thank the KDEV for enabling me to work on this. I want to thank everybody who was involved in converting all of the frameworks from the old syntax to the new syntax, because I did not do that all alone by myself. I want to especially thank the documentation infrastructure team at the Qt company for not only taking my half-baked patch and pushing it across the finish line, but also for being super receptive with bug reports and feature requests that I had for QDoc, because while QDoc was mostly a very good fit for KDE, in good KDE tradition, I sometimes managed to stretch the limits of the system a bit, but they've been super helpful with addressing that. Since we are in a somewhat academic context here, I also have to cite that we are using GNU Parallel for parallelizing the documentation build process. I want to thank Ben for assisting me with getting the infrastructure pieces for this rolled out. I want to thank Carl in particular and some other people for helping with the web design aspects of that, because I am not a magician with CSS. And I want to thank you for listening to me today. And then let's have a look. That's anticlimactic. Woo! So as you see, the header is the same thing we're used to from our other sites. We have some general introduction for the libraries. And then we have a list of all the frameworks. So let's have a look, and let's take an interesting example, one that did not work very well before, which is Kirigami, because that is mostly QML API. So once again, bit of introduction text, and then we have specific references to all the submodules that we have in Kirigami. You can have like the general Kirigami types. You get a list of all the classes that are available in QML here. And if we look at, for example, action text field, you can see it from the structure, it looks very familiar to what you know from the Qt documentation, because surprise, it's the same tool. It's just slightly different style sheets. It's blue instead of green because branding. But it tells you import or KDE Kirigami. It inherits from text field. If you click on that, you get forwarded to the Qt documentation site like you expect to. You get all of the properties and so on and so forth. And it looks like actual QML API documentation instead of whatever we had before. So let's look at some C++ API. You get like the proper CMake instructions, find package KF6, and so on and so forth. You can look at the C++ classes and, for example, KDescendants proxy model. It tells you all the things you need to know, like what to include, how to use it in CMake, what it inherits, and then it looks like C++ documentation, so have fun with it. Thanks.
If there's any questions, the obvious answer is read the fine documentation. But since there are questions anyway, I'm going to run up there. If you can answer in that microphone, that would be great.
Yes. Is there any hope to automate pulling out the type that the property maps to in QML, that you don't have to do it manually?
That's a question for the guys sitting in front of you, possibly. But I believe something like that might be on the radar.
Do you have anything to say about that?
I wouldn't know, at least not from the top of my head. Maybe Kai has an idea. But since I got the microphone, thank you. Question that we are struggling with is, you mentioned the dependency situation. What we would like to do better is to reference the QML way of using an API in a module that is downstream, or upstream rather. So for instance, QCore documentation, how to use abstract item model from QML. We can't do that because we have the same problem that you mentioned, dependencies to... Is your solution something that you think would work for us in Qt as well, or is it very much tied to the KDE build system and structure?
The Qt documentation build and the KDE documentation build are a bit different in the sense that with Qt you have a single unified build system that can build all of it. So you can have a documentation build that does all of it, which is actually much simpler than what we have with a bunch of different projects that don't have a common super build. So I'm not sure why you would have a problem, because Qt core can just documentation depend on Qt declarative, and I believe it does already.
Okay. Maybe something to investigate for us in more detail.
All right.
Maybe it's not a question for you, but for other people in the room, are there any plans to make QDoc really parallel instead of just using GNU parallel for that? Because it's somewhat slow if I wear my desktop package just had.
Great, I can outsource
Speeding
the
up.
answers.
Yeah, so yeah, we've been working on, from the Qt side, from speeding up QDoc for quite some time. Never got quite there, but there is still hope to actually make it more parallel. I mean, yeah, the downside is basically, I mean, it's using Clang, so it by definition will be, or, you know, it will never be like lightning fast, because, you know, Clang is doing the whole magic and including every single file and so on. But yeah, it's right now QDoc can be slower than actually compiling the whole thing, which is a bit frustrating. And yeah, it's on the agenda.
All right, we have one question in the room, but there's also one online.
Are you going to attempt to kind of unify some of these other documentation sources as well, now that you've done the API KDE.org? Because you listed a bunch of them in the beginning.
So, as I've mentioned, I think it's worth thinking about incorporating the existing remaining developer documentation, like develop KDE.org, into that system, because I think that can technically work very well. I think for the user documentation, so what is now docs KDE.org, it doesn't make that much sense, because it's a very distinct audience, and the tools that are used right now are also completely distinct. We're using DocBook for that. I don't know if we're going to stick with that, but that's a sort of separate discussion. And then, as far as the wikis are concerned, I think there's always going to be a case for having a wiki of sorts, but I would argue that most of the developer-oriented documentation that is still in the wikis should be pulled out to sites like API KDE.org or develop KDE.org.
Okay, then we have one question from online, from Rick. It seems that some existing information from the previous api.kde.org is not carried over very well, namely licensing, cross-platform support. Those aren't presented very clearly. Are there plans for that?
Yes. So what you're seeing here is subject to be tweaked and evolved. We have some degree of freedom in what information we present and how we style it. So cross-platformness is definitely something I want to address. Licensing is also something that is certainly important. And there's also some existing work there on the QDoc tooling side with automatically pulling SPDX information from the actual source code and using that to display something. Something that I've been dreaming about for a while is going a bit beyond what we currently had with the license presentation, where we just say, okay, this is LGPL, or this is GPL, or this is MIT, and have, or at least link to some sort of resource, okay, but what does that actually mean? What does it mean to be GPL or LGPL or MIT? But that's for another day.
First, thanks for the new documentation. It's great, and I really enjoy using it and makes QML much easier in particular. But I often found myself still going back to the old one because, as always, sometimes the real documentation is the code. And in the old documentation, you just click on the file name and get the actual source code and look at it in detail how it works. And the one doesn't seem to have that. Is it possible to get that back somehow?
I would think that this is first and foremost a tool question. I haven't looked into that, but I can't promise that it would be easy.
All right, I think that wraps up this section. On the clock. So let us thank the speaker. And next up in this